Hi, welcome everybody. I'm Peter Abil. I'm here to introduce our speaker of today, Daniel McKinnon. Daniel is the enterprise product manager at 3D Robotics. Before that, he actually already had quite a bit of experience in working with drones. He built a drone for wildlife observation and capture for the Denver Zoo. He also started his own company, Robotics, working with growers and agronomists to develop front-end data collection and back-end data processing solutions for their needs. And today he will tell us about how some of that has worked its way into 3D Robotics and new things he's working on at 3D Robotics. Please help me welcome Dan.
All right, great. Well, thanks a lot for the introduction, Peter, and thank you all for coming here. 3DR is actually a local company. We are just down the street. We're at 4th and Virginia, so it's really excited to be here and tie in more closely with the Cal community. So 3DR is basically about helping people see their world from above. So we make these little flying robots that carry different kinds of cameras and sensors and provide a whole new layer of information that people have never gotten to see before, or at least not this accessible and this cheaply. So 3DR started a long time ago as kind of a DIY, hobbyist, soldering iron carrying product vendor. So we made these breadboards that were originally based on the Arduino processor, which for those of you doing all this robotic stuff know is a pretty low-end, hobby-grade kind of microcontroller. These kits went into all kinds of different research and hobby vehicles, and it was really the first time anyone outside of the military could make an autonomous flying robot, an autonomous flying rover, a boat, and all of a sudden, for a couple $100, anyone in the world could make something that would navigate on its own and collect whatever information you needed. So that was founded by Chris Anderson, who's our CEO currently, and he was the editor at Wired magazine for a long time and got very interested in this stuff. And Jordy was actually just a member on the forum that Chris had developed around these robots. It was called DIY Drones. So it was a really interesting start to a business. As these two met online, they discussed about how they could make these autopilots better, and then they founded 3DR. Then after a few years of kicking around in the open source community and kicking around development, there was a group at ETH in Zurich that decided they wanted to upgrade from this Arduino-based architecture to a more sophisticated architecture, and this Pixhawk was developed, and this is kind of our current autopilot we make. And what's so cool about this is it brought it from this fairly narrow community of people who want to solder together little computers and who want to really do a lot of hardware development to more people who can just plug different motors into these different ports, and it's really an off-the-shelf kind of solution for building your own drone. So this community expanded, and there's a lot more people who had access to these autonomous robots. And then we kept doing more work in this area and came out with some really hobby-grade, ready-to-fly things that started to change from the person who had to have a lot of hardware knowledge, who had to know about firmware and protocols and all these different serial protocols, to somebody who said, okay, I want to start being able to build on these just from a software perspective. And you could just buy a helicopter or a quadcopter or a fixed wing directly from us, and you could monkey around with the flight code and make it do interesting things. This is a very common platform in university research for UAVs, and people were able to use these things to do some really remarkable things, whether it was counting chimpanzee nests in Borneo for the first time or monitoring deforestation or Rwanda. There's all kinds of awesome university research that sat on the back of this platform. And then now what we're doing is, and then there were also a lot of consumer products that were built around this. So essentially every single consumer drone you see out there, aside from DJI, is built on the back of this technology that we've put out there in the open source community, in addition to some software. And so then what we wanted to do is we wanted to expand that community even further. So from the people who are really like hardcore flight code people to the kind of people who might want to write an app that sits on the cloud or in the tablet or even on the vehicle. And the reason I'm telling you all about this is that's how this journey into ag is going, is people are able to just write some software that allows this flying robot to do essentially whatever you want. So what we have here is the product that we're selling right now that is used for a lot of our ag research. It's called Solo. There's a computer that sits inside that's a full-fledged Linux computer that runs a Debian stack. You can write whatever software you want to sit on there. We have open APIs to write your own software for a connected device. And we also have an API in the cloud. So if you want to process those data in the cloud, you can do that as well. One thing that we're really excited about with this platform is we have these 2 open accessory bays. And so right now I just have a GoPro camera sitting on there. This is what people generally want for consumer. But there's all kinds of different thermal and multispectral imagers that people are using, particularly for applications like ag. And you can basically take this open platform and plug things into them, write your own software, and be able to do a lot of this like innovative commercial and research applications. So we're here to talk about ag, and I just want to present something to you to get this discussion started. This was a figure that made it in, I believe, a 2012 AUVSI study. The AUVSI is the leading trade group for unmanned vehicles. They're very defense-based. Their members include people like In Situ and AeroVironment and Boeing, and they decided that they wanted to learn about how people would use drones in the commercial marketplace. As I mentioned, in 2009, you had to be a very hardcore hobbyist to make one of these things, but now you can buy this at Best Buy and you have an autonomous flying robot. And they wanted to figure out what people would use them for. So they did some surveys and they had some research methodology, and they came up with this graph right here. And you see there's this huge chunk of agriculture and then public safety and other, whatever that is. So why is this? Does anyone know? Why do you think? What springs to mind as to why agriculture is such a big market in this ABSI study? Yes, yourself. That's what you get for sitting in the front.
Okay. Well, I think you need to, if you have large fields, you need to see what's happening in the field. So instead of going on the ground, which is very hard to get an overview, if you can fly, you can see if there's watering issues or blight issues, those kinds of things. So being in there is really advantage.
Yeah. So that's exactly right. They're these large fields. They're inaccessible. They tend to be in remote areas. There can be problems that arise, and you would never even know about them. So that's what we'll talk about today. There's a few other issues here. This is basically the economic side of things, is you have these large fields which are really, really complex optimization problems. The amount of what we would in this room call engineering that goes into farming is insane. You have to match your seed hybrid to your soil type. You have to match your seed hybrid to how you project the weather to behave next year. You have to fertilize each management zone in your field correctly, making sure that it matches what your hybrid is expecting. You have to irrigate right, knowing what the economics are and how much irrigation you have. So this is an enormous optimization problem, and feeding more data into that problem, especially that's spatially resolved by drone, is really helpful. But the other reason is this regulation issue. Is right now there's a lot of concern over when do you use drones? Where can you use them? How high can you fly? How low can you fly? Who can you fly over? Can you fly over anyone at all? There are so many industries that are being disrupted by this technology. But in ag, you generally have people that are interested in observing private land, so there's no privacy concerns. It's very safe. There's not that many airplanes in agricultural land. When you do get things like crop dusters, it's very easy to know when they're coming because the person who owns the land is generally calling them. And this is generally, prior to a very recent FAA ruling, was considered non-commercial, as you were just using it for your own benefit. This has since been reversed since I made this slide, which is unfortunate. But ag is a really nice test case for you're out in the middle of nowhere, you can fly these things, and there's not particularly high consequences. So what actually happened was the FAA started this process. It's called a 333 exemption process. And it allowed commercial operators to fly drones legally. And it's actually very easy to get one right now. This is out of date. There are now thousands of these things. And you basically just write the FAA and say, you're going to be flying these things. You're going to be flying, say, this airframe. And I have a at least sport pilot's license, which is a little certificate you can get. And I can operate these commercially. And it turns out, which is probably not surprising, and the ABSI definitely missed this, is that film is by far the biggest application for these things. Every single Hollywood movie you've seen recently had scenes filmed by a drone. Wolf of Wall Street was the first big one that had a famous drone scene, but Mad Max, that was actually filmed almost exclusively by a drone. Every single movie is getting filmed with these things because they just allow you to capture footage, even when they're close to the ground, that you couldn't capture otherwise. Survey makes sense. This is also a really big application. You probably see people. In fact, who saw the helicopter flying overhead today? Yeah. Does anyone know what that helicopter was doing? Oh, it was a background. It was not a survey helicopter. Okay. I thought I saw a LiDAR hanging out the front. In fact, I wouldn't be surprised if it also had one of those. But this is a big application for helicopters. You'll hang a LiDAR underneath these helicopters, and you'll just fly back and forth, and you'll collect a map of an area. And that's something that you can do with a platform that's literally 1,000 times cheaper. But ag is still big. So there's a lot of people who see this as a really nice market to be able to collect data for their uses. So very briefly, what my background is, how I got involved in this was I was doing my PhD in chemical engineering, actually, at University of Colorado. And I was involved in a program similar to Citrus. So there was a lot of incubation and entrepreneurship. And I got involved in a project with the Denver Zoo to build a quadcopter to observe vultures in Mongolia and actually drop a net on them. So the Denver Zoo wanted to, yeah, no, that's a true story. It sounds insane. Cinereous vultures are the second biggest bird in the world after the California condor. They live on these rock pile, these spires of rock. They used to migrate from Spain to South Korea. The Spaniards started feeding them, so the ones in Spain don't leave Spain anymore. And the South Korean ones are now endangered because the North Koreans shoot them as they migrate from South Korea to Mongolia. So the Denver Zoo has a huge project, and they want to know how they migrate. But to know how they migrate, they have to put these little backpacks on them with a radio tracking beacon. When these vultures are living on top of these huge rock spires, you can't put a backpack on them. So they had this idea that they would hire me and a couple other people on this team to build them a quadcopter that would fly a net up, and it would drop a net on the vultures. It totally worked at the zoo, but they just flew away when we actually went to Mongolia to deploy this. So it was unsuccessful from a catching vultures perspective, but it was very successful from, I had 3 weeks in a yurt in Mongolia in the middle of the Gobi Desert to think about what I wanted to do with this. And we had a farmer with us who was actually a cocoa bean farmer, and we had this idea of doing this agriculture thing. So started this company called Robotics. Actually, my dad was one of my co-founders, and learned a lot. And they're still going strong, so I get to keep pinging ideas off them. The first thing I learned is that growers do not want to become drone pilots. So at that point, it required this controller that had all these switches and a desktop and some really heavy software to be able to make one of these things fly around autonomously and make a map of the field. That was like a non-starter for somebody like a farmer. It had to be push the red button, have the thing take off, automatically collect all the data, send it up to the cloud to be processed, and then put the data back onto the tractor. We're even now not quite there yet, but this was like a really good realization, is making this technology simple is the most important thing that we can do. Growers also don't want to become imaging experts. I'm going to show you some very simple image processing stuff that I've done that's really effective for growing. I think everyone in this room is probably some kind of PhD student, faculty member, background in engineering. So you'll see this and you'll say, okay, this is simple. Tell me more. I want to learn about this. But this is not like a typical behavior. Many people just want something that works, and they just want the actionable data out. They don't want to have to do any of the analysis themselves. So They just want this tool that provides them actionable intelligence. Should I use more fertilizer? Yes or no? Should I plant this hybrid here? Yes or no? Should I water more? Yes or no? And we're not quite here with the yes or no, but we are here with the be able to prescribe very specific behaviors from the data that the drones collect. So this is just to come back to your point about what you need the drone for. This isn't actually a very good picture to demonstrate the point. I just really, really like it because this is in Colorado. This is right by my house, and that's Long's Peak in the background, and this is like a really beautiful field that was one of my test fields. But this was 200 acres of corn. Right there, the corn is short, so you can pretty much see over it, but you actually have no idea what's going on even 10 feet or 100 feet in front of you from the perspective of the health of the crop. So these fields are essentially endless. Here's barley. This is a different field. You can see that, if you wanted to know what's going on right here, you would have no idea. And the more we get these out here, the more we realize that there's so much heterogeneity in these fields, and it's really helpful for a grower to be able to understand, wow, I just lost 20 acres there because of X. If I wanted to walk through this field, which I did here because I was ground truthing some data I collected, I was up to my shins in mud. You would never do this. So, there's this really complex problem of optimizing all the inputs into farming. And there's some remote sensing companies starting to provide solutions, but this UAV collected data is just this totally new data stream. So how do you collect it? Do you have to collect it fast, or do you have to collect a really accurate map? This was something else that I learned a lot about while going and flying hundreds of these farms when I was with AgRobotics, and I still do this to some extent now. This is a map of a field in Colorado. This is the reason it's a circle is, who knows why it's a circle? Why is it a circle? Irrigation, right? Because it's this one actually has a fancy center pivot, so it's got a little thing that sweeps out the corner. But generally, when these fields are irrigated, which they are essentially 100% of the time, about west of the Mississippi, they'll always be I shouldn't say always, oftentimes they're in a circular shape because it's cheaper. But this is you can't see because this projector isn't a high enough resolution, but this is a 2-centimeter accuracy map of this field. You can zoom in on that map and you can see individual blades of corn. That's really good, right? That's what you would want to give these people. They could go and almost see a bug on their blade of corn. One would think, but actually this is also like a 5 gigabyte image file that you can't open in any kind of viewer, much less anything in the GIS world, without tiling it into some kind of more difficult file format. So it turned out that this wasn't quite what we wanted, and getting the resolution at the level of the leaf is not super high priority. And then, okay, and here's a slightly more zoomed in version, but this is, I believe this is the second, it's the same image. But, kind of the alternate extreme is you can just tile the images, and you can just, one of my collaborators at Monsanto called this the Tinder of ag. So you can just have your field app, and you can just swipe back and forth and say which ones look good, which ones look bad, and then all of a sudden you have geolocated areas of your field where you actually want to see. And strangely enough, this is actually really interesting to a lot of people, is the super fast, super low resolution. In real time, as the images are being taken, they're coming to your phone, and you're swiping back and forth and deciding where, and then it kind of pinpoints where your problem areas are. So there's this balance between speed and precision, and we're still striking as to what the growers actually want. So what are these images actually useful for, other than just swiping back and forth and deciding what's useful? It's amazing how much information you can get from a simple color picture by just taking it from above. So can anyone recognize what's wrong here?
Something's wrong with the sprinkler.
Exactly. So what happened is this is all wet, and there's this dry streak. So that's a clogged spray head right there. So if you do the math, and that spray head weren't unclogged, that's like a couple percent, 2%, 5% of that pivot having a clogged spray head. It affects beyond this dry streak because there's only a limited number of spray heads. And that kind of information is really easy to see here. I can tell you from experience, and you probably will just have to believe me because I don't have a picture of it, but if you're looking at a pivot going around a field and it's sunny and the thing is on, you just see rainbows and you see mist, you have essentially no way of determining whether one of these spray heads is clogged. So this is a super compelling use case for just a color picture changing how farming is done. This is also really interesting. So in organic farming, what you do is, well, let me just step back. What you do in conventional farming now is you do what's called chemically fallowing your field. So at the end of the season, you just spray herbicide on your entire field and let it go fallow, and then you either replant next year or have it fallow, depending on what your cycle is. In organic farming, you can't do that because you're not allowed to spray these herbicides on your fields. So what you do is you plow, and you plow, and you plow. And what happens when you plow too much? Erosion. You lose all your soil. That's like Dust Bowl. That's why that happened. And so there's actually some pretty compelling arguments to be made about like the drawbacks of organic farming, given the extreme amount of plowing they do, which from a fuel and an erosion standpoint is like a big problem. But this is an organic farm, and right now what they do is they say, I think I have enough weeds there that I need to plow my whole field. But I don't know right now. So this whole thing that's a mile long and it's a half mile wide. So that's a pretty big area. And now, when they have just images overhead, you can pick out all the weeds using some simple vision algorithms, and then you can say exactly 30% of my field is covered with weeds. I know that will cost me this much in lost revenue. It's time to plow. Or not. Or 10% is covered. That's actually okay. So that's all really cool, but that's not as interesting as some of the technology available out there with these infrared cameras, which is really where this movement is going. So leaves have something called a spongy layer on the backside of them. The entire point of that spongy layer is to reflect infrared radiation. So an IR photon does not have enough energy to kick off the photosynthetic cycle, so it would just be heat if the plant weren't able to reflect it. So a healthy leaf or a lot of vegetation will reflect a lot of IR light. A dead leaf will not. So it's a very, very nice way of determining how healthy vegetation is and how much there is. This is taken advantage by these kinds of pictures. This is from Landsat, and this is using an index called NDVI. How many people here know what NDVI is? No one? Okay. This is some really simple arithmetic. Essentially, it's the IR signal subtracted the visible signal subtracted from the IR signal divided by the visible signal plus the IR signal, and you basically get one number. It's between -1 and 1. And then it's false colored on a map like this, and you can see just generally looking at this map of the world that it's doing a pretty darn good job determining where there's the most vegetation. This is much more striking than, say, a simple visible map of the world. So people have really promised the world of these different indices. The idea is that you can fly one of these IR cameras, you can fly over your field, and all of a sudden you know every single thing that's wrong with your field and every single way you can improve. Let me just show you a picture. This is a map behind NDVI. This is an IR picture of a field. What's happened is this camera has had the IR blocking filter removed, and then it's had a notch filter put in that takes out actually the green color. So essentially this is a modified consumer camera, which does more or less what that Landsat does. So you'll notice that red is now green. So you can see this is a strong IR signal. And you can generally see by the naked eye that there's clearly like some fields that are fallow and some fields that are not. When you do this NDVI math on there and you actually scale those pixel values and false color them, you see something really strange. So I use the same false coloring that the Landsat did, where green is a strong signal and black is a weak signal. And you'll actually notice that the tractor is green, which is really weird because it's not a plant and it doesn't reflect that much IR light. So you end up with these weird scaling artifacts with shadows and things like that. So the type of math that's used for Landsat that's really effective at determining where vegetation is when you've got a satellite out there might actually not be the type of math that's effective using a drone that has an IR camera. So let me show you something else. So there's, again, you can see that this doesn't quite correlate here. Is if you just take something called a different vegetation index, just an unnormalized vegetation index, or DVI, and you just subtract without normalizing, you can see you actually get a really nice result. This is telling you where your crops are. This is telling you where your vegetation density is. The tractor is no longer a plant, and you can clearly see the difference between plant and non-plant. So this is kind of a big breakthrough here, because there are a lot of people using NDVI, and there's a lot of confusion about how this actually works and how you apply this. So now this is working. You know, this is like in grad school, and you finally get your experiment working, and then you actually have to do something with it. You know, how do you actually use these images? And we really came to some remarkable conclusions at AgRobotics that people are still doing right now. And we actually have a 3DR product in the field that's getting sold with the same technology. So this is an image of a field. I believe this is that same organic farm that I showed you before, back when it was fallow. They're growing wheat here, so wheat is just starting to pop up. There's nothing there, and there's probably, I think, barley and oats on these other fields. So what you'll notice is that it's doing a really good job of identifying these fallow fields, and it's telling you where you have the most vegetation density. So you show this to the grower instantly, and they say, hold on, what's going on here? You cannot see that at all from the side of the field. You maybe can see it with color images, but it's striking in these vegetation index images. And what that is their planter actually accidentally double planted these rows, which is a huge problem in dryland organic farming, because the amount of water the double planted rows will suck out of the earth is so much higher than a single planted row that they'll suck it out in the start of the season, and then it won't be replenished, and they'll end up with actually poor yields there. So this is kind of just a sample use case for this. They were looking at weeds in this other field, but what's most exciting is just being able to determine what the density of vegetation is in these fields. So this is that same barley field that I showed you before. And you're going to have to take my word for it, but you also did see a picture. This field looks identical, totally homogeneous from the side and from the air. You would think that there was absolutely nothing different about this field. But you'll notice that there's this spot here, and then there's that corner up there where you have a lower vegetation density. So what's going on there? So this is actually when I was up to my shins in mud going and checking it out. And in this bright green area, what you see is, look carefully for these things. This is called the head of barley, and so this barley was heading right now. So that means it's got a big, fat seeds on top. That's going to be a very good harvest right there. This is actually being grown for cores, so we're all going to have great beer because of the green parts of that field. When you go to the yellow parts, actually, oh no. Do I not have my yellow parts? Okay, all right, well, I must have deleted that slide on accident. Anyway, you're going to have to take my word for it. These things are gone. So that grower could totally predict his yield before growing time and make a decision about when he wanted to lock in his pricing based on what he saw from his vegetation index. Because it turns out, this is not totally non-obvious, but some people don't think about this and certainly weren't at that point, is the more vegetation you have, actually the better your yield is. You'd imagine you've got barley that has lots of leaves, or you've got corn that has lots of leaves. It's going to have more energy to put into making that seed or making that fruit. So that's barley. With corn, it's even more striking. And corn is the absolute most compelling use case for these things because it's so expensive to grow corn, and there's so much money in growing corn. So this is a 100-acre field in Missouri, and you can see that it looks totally heterogeneous. Like, you can see obviously which way they were planting and fertilizing. It was vertically. You see the stripes. There's some kind of band in the middle that is much stronger than the other ones. Is this real? What happened here? So if we just zoom into the corner and we take a few pictures on the ground, where it's green, this corn is chest high. So this was maybe in July, something like that. I don't exactly remember, but midsummer. That's like where it needs to be. And in that red area, it's ankle high. You would never know that if you were looking at this from the ground. And then in the yellow, it's somewhere in between. You know, it's maybe this knee-high corn. And this works every single time. This was really an incredible breakthrough. Okay, so what do you do with this? Why do you care how tall your corn is? You can predict your yields, but what's the action you can take on that? The action is a simple mass balance. This is like very fundamental chemical engineering. Are there any chemical engineers here? Yes, mass balances, good. So you've got soil. It has a set amount of nitrogen in it that you can measure at the start of the season. And you've got corn that's pulling nitrogen out of the soil so it can grow. And then you've got fertilizer that's putting nitrogen back in. If the corn has pulled out more nitrogen than you've put back in, you're going to end up deficient in nitrogen, and vice versa. So what you can do is by calculating how much your corn has pulled out, you can calculate how much you need to put back in. What's so interesting about this for corn is it's actually, you do what's called top dress 3 times a year in the corn belt. So you apply more fertilizer 3 times a year because you don't want to apply a ton at the start of the year and have it all wash out in the rain. You want to be able to kind of more microdose it. So what you can do now is go from that map using this mass balance to management zones. So this is a cornfield. I think this is in Kansas. And this is actually chunked out into 30-foot by 30-foot management zones, which is the resolution of the sprayer, which is what puts down the fertilizer. And all modern sprayers have this technology. This is totally universal, but until drones came around, there was no way to actually use the variable rating technology. So this sprayer will be driving along, and it might be spraying, 50 pounds an acre, 50 pounds an acre. Oh, and then it hits a green one, and then it needs to go up to 60 pounds an acre, and then so on and so forth. So you're actually variable rating the fertilizer which is the most expensive input in growing corn, by how much is actually needed. So this is actually pretty incredible. And so what's missing? I'm working on this a lot at 3DR, is just making this really easy to use. So you got to push fly to take off. This all has to be in mobile. It all has to be cloud connected. I'm doing this. We're living in the future. You guys are in a tech world, Silicon Valley. You know this needs to be easy to use. And there's also tons of other applications. So ever since we started selling this solo AGCO edition into AGCO dealerships, we've got guys who are growing sugar. The largest sugar producer by far in the US is using these all over their fields, which with sugarcane, you would never, it's so dense you can't even see the next row, much less 100 yards over. So they're using it to be able to, they do all their spraying by airplane, and they're using it to optimize that. And there's a couple other cool products that AgRobotics has made recently that I just wanted to share. There's a different spectral signature between these Roundup-resistant weeds and the annual weeds that they found in some of these fields, so they're able to differentiate between those two. There's a lot of infrastructure type work in agriculture that's going on. So this is in Sumatra. The palm oil plantations need to be able to grade roads through their plantations, and they need to optimize the path of those roads by how close they are to palm trees. So you can see that they're able to chunk out different palms and see how far they are from a road and help them develop new roads. And then they can just count stands. So when you go around and you plant new corn, sometimes your planter will clog, and then you'll miss areas or your corn won't germinate, and that can have a tremendous impact on your yield. And by making these types of maps, you can determine whether you should replant. But what I really want to do in the last 5 minutes is just kind of share one big reason I'm here is 3DR drones and autopilots have pretty universal adoption in the academic community, and whether it's robotics, whether it's GIS, whether it's ecology, people using them for different reasons. We've just relaunched this 3DU program where we do academic discounts and we give free autopilots out, and we provide a lot of support, whether it's technical, whether it's exposure, whether it's helping connect researchers doing the same thing. Unfortunately, our academic director couldn't be here, but know this exists. It's 3dr.com/3du. We help people study their world from above. And also, we are in infinity hiring mode. 3DR is scaling really fast. We're growing as a company. We want lots of smart engineers, whether they're hardware or software, to come join us. So email me and come work with us. And any questions? Yes?
How do you sell this to a farmer?
Well, fortunately, I don't have to sell it to a farmer. So, yeah. Honestly, what the value prop is right now is I want something fun to play with. What the value prop is in the future is, so we're doing it with AGCO, which is a big ag parts distributor, and they're going to their dealerships and they're explaining how you do these different maps and how you do these different management zones, and that's kind of on our end. We're really good at making drones and software that runs drones, and AGCO is really good at selling things to farmers. Yeah.
So in robotics, you usually talk about sensors and actuators, right? And the drones, the sensing side, you have this controllable, whatever you call it, this sprinkler, right, that can control itself. Are there other existing pieces of equipment that you can sort of hook into, right? The whole ecosystem function?
Yeah, so variable rate irrigation is at really the forefront of ag tech. So that's there, but it's not super common. Variable rate seeding definitely is, and that's the second most important one behind fertilizer. Seeds are extremely expensive in this world of custom GMOs and hybrids, and being able to determine on what aspects you should seed at what density based on different soil types and last year's performance is huge. Yeah.
Because I know computer vision can usually be not that accurate depending on the lighting and other factors.
Yeah, so it depends what you mean. If you're talking about like the vegetation index results, these are absolute gross approximations. So right now, an agronomist would really a forward-thinking agronomist would measure nitrogen content in the soil and put a gross recommendation out, like this field gets 50 pounds an acre over the entire field, without considering different spatial zones. Right now, it's still work in progress determining whether if you have this much vegetation density per square meter, you bump that area up to 70 pounds an acre and this one down to 30 pounds an acre, so the mean is still 50. So from that perspective, I guess it doesn't really need to be that accurate because the baseline is 0. So I guess there hasn't been any effort to say that this signal actually means this exact vegetation density.
I have a question. Hi. Firstly, thank you very much for sharing your work. It's actually very incredible what you're doing. My question is, you talked about health of the plants, like different kinds of plants. Did you optimize it for different kinds, or was it the same thing for what you did for corn and what you did for sugarcane?
So I did not. This is definitely something that end users are doing right now. And there's a lot of this is very much still at the R&D phase, whether it's an individual farmer doing his own experiments, whether it's a university. Kansas State is super, super active in this area, but I don't know. Yeah?
Is AGCO currently the only distributor that you're working with?
The only distributor in ag, yeah.
Okay.
Yeah.
Yes, thank you very much. I suppose that the drone doesn't do all that much flying. I mean, once you determine, some characteristic you're looking for, then you just don't fly it until some next time. I'm guessing that. I wanted to focus in on your vulture question. The vultures flew off, but I didn't know if they were flying away from the drone or they were just flying. And so I'm wondering about the interaction of the drones with wildlife, whether that would be a problem, or is it too rare that you send the thing up that won't be a problem?
Yeah, that's a good question. These vultures were definitely flying away from it. They didn't like it. I can say from flying around here that city birds definitely do not like these things. I think part of the reason is that they're too loud right now, and that's something that we're working on. These, in fact, something just kind of interesting from an engineering perspective is these props are just plain props. There was zero effort that went into designing a multi-copter prop. And you can get much, much quieter vehicles by putting little winglets, just like you see on the Southwest 737s, or I think every airline has them now, and reducing like turbulence and making these stiffer. So I think reducing acoustics is a priority, and I think that would help a lot with wildlife. There's actually a great paper that just came out. I think it was in PLOS One, and it was the impact of drones on the resting heart rate of bears. I kid you not. We just put it on our blog because we thought it was so funny. And the answer was they didn't really mind. But I think it probably depends on what it is, what the animal is.
But their heart rate still went up when they came by.
Yep, their heart rate went up. Yep. You saw that paper? Yeah, pretty funny, huh? Yeah.
How long will it typically push on the
Yeah, so 20 minutes is our conservative battery life. That's about 60 acres when you're looking at the resolution that you'd want for a farm. Yeah.
So what kind of payloads do you have? Just basically color camera and anything else?
Yeah, so the only thing that 3DR has right now is the GoPro payload. But there's a bunch of different third parties in the community that have put together different IR cameras or thermal cameras, or a lot of it is, since we did come from this like open source hardware hacking community, there's a lot of like DIY aspects to it, but internally we are also going to make our own payloads.
So for using like the imaging we're doing before, do you use GoPro or?
Yeah, so those were actually taken with a modified Sony camera, but I have an IR GoPro right here. So yes, you can do them with GoPro too. Yeah.
Two questions. So, any thoughts on how the visual data can go to diagnosis, like distinguishing nitrogen deficiency from soil quality from other factors that might lead to reduced growth? And then second, can you talk a little bit about the relationship between agrobotics and 3DR and what that looks like?
Yeah. First question, what's the diagnosis? It really depends on what type of field it is. There's significant agronomist knowledge that still needs to go into that, and generally they'll know. So what I found is you go out and fly a field and you see that the right side of the field looks terrible and the left side looks great. This is a real example. And the grower says, God damn it, that pesticide carryover from last year is still persisting. And what happened was his neighbor had sprayed too much pesticide and it drifted onto his field and it was the wrong kind. So in most cases, they will know. They know their fields, and they know what's causing these issues. There's some cases where you can pull up the USGS soil maps, and the vegetation density literally falls right on top of the soil type. And they know. And this comes back to your question about seeding, is some hybrids are more appropriate for different types of soil. And when you really start to internalize that, you can actually make these good decisions. Relationship between 3DR and agrobotics, none really. We did the AgCo product with them essentially because I was just familiar with the agrobotics software. I don't know. They're one of our platform partners. I came from there, so I'm intimately familiar with them. But we did that product together.
Yeah. Do you foresee this instrument aiding firefighters in the inferno if it doesn't melt in the fire?
Yeah, absolutely. These guys got a little bit of bad press recently with the fires in Southern California. And that sucks that there were irresponsible people that were flying them inappropriately. But we get inbounds from firefighters, public safety, search and rescue all the time. Yeah.
What is the biggest challenge to creating this kind of push and go kind of system? Would that be like navigation?
Yeah, that's a really good question. Right now, navigation control is like pretty good. Strangely, you have a lot of ex-missile people in the consumer drones world right now. That's where they're all going now. And this thing, like, I have 100% confidence that it will fly where I say it should fly, where it thinks it should fly. The issues with like the really touch and go are making sure it's getting the right data into its Kalman filter. So, for example, your magnetometer can't go bad, or your GPS chip itself can't go bad. But that's not becoming an issue with these things anymore. It's really more of a UX, software, mobile app, easy cloud connectivity, more traditional software engineering problems that are preventing these things from being even easier to use. And this is pretty easy to use right now. Yeah.
So I know for some time now, one of the biggest complaints that the unmanned aircraft industry has is that the FAA has been dragging their feet on getting good regulations out, regulating especially commercial drone use. What can you tell us about the current regulatory environment, especially in the United States, for deploying commercial unmanned aircraft solutions, and what is FAA doing right now, and how is that going to affect your business?
So we do 99% of our business to consumer. So it's not going to going backwards. It's not going to affect our business, even if the FAA decided commercial use were outlawed. Right now, it doesn't affect things very much. The process right now is a little bit burdensome, but it's not bad. You get a 333 exemption for universities. You can still go through a COA process, and with that, you're allowed to fly anywhere outside of major urban areas under 200 feet whenever you want if you have at least a sport pilot certificate or a rec pilot certificate. It's pretty straightforward to get all this stuff. I think that they should lower that to the NPRM, or the National Proposed Rules that they sent out for review maybe 3 months ago, that would let you just get a license. That it'd be like getting a driver's license. The FAA really, really needs to come out with some real guidelines for how you fly these things, both as a consumer and as a commercial operator, though. And we want to be regulated. We're self-regulating right now. Google is really taking the reins and doing an awesome job putting together this coalition of UAV manufacturers. And I'm really happy that they're doing that, because the FAA is not. But yeah, this whole industry is screaming, like, let's just fix this, regulate us. Yeah?
When is something a model airplane, and when does it become a drone? Because I was used to flying model airplanes and had no license or anything.
I would love to know. That's one of these regulate us questions. FAA, we will do what you say. Like, we just need some rules that we can follow.
Final question, where is that place?
This is in Cabo, and this was at one of our tests, and I wanted to have this video in the background of the Join Us slides so you can see the fun trips that people go on at 3DR. But it looked weird with the pictures of our holiday party, so I put it in the question slide.